Okay, and here we are at problem number 7. This is an interesting one because it is what is the area of a trapezoid? And in this one we are given the lengths of all 4 sides of the trapezoid. So that's supposed to make it look easy for us. But what's the formula for finding the area of a trapezoid? The formula is very simple. A plus B over 2 times H. And in this case, A is going to be this top side here, which is 10 centimeters. B is the bottom, which is 24. And we don't know H. We have to find it. H is going to be the height from the top line to the bottom line. And we can pretty much come to the end of the top line since it's the shorter one. And we can draw straight lines down to the bottom line, and we're going to form a 90-degree angle with the bottom line. We've formed a square in the middle, and so for this square we know that the top is 10. Because it's a square, that means the bottom is going to be 10 centimeters as well. So we can just, if we call this one X, and then we call this one over here something, I would say that we've got 24 centimeters to begin with. You subtract 10 from that, that's 14 centimeters that's left. So 14 centimeters has to be divided between X and this area. So let's say this is going to be 14 minus X. And that's how many centimeters this is. Go ahead and put parentheses around it. There. That leaves us with a situation here because we want to find out what H is. And the only way to do that is to solve these triangles to get H. So using Pythagorean's theorem, we can come up with an equation for this triangle that we just formed here. This is a 90-degree triangle. A 90-degree angle, which means we have a right triangle here and another right triangle here. So we could definitely go after Pythagorean's theorem. Since we have 2 variables that are unknown and we have 2 triangles to work with, we'll go ahead and make 2 equations based on Pythagorean's theorem. So we're going to say 15 is the hypotenuse on this one, 13 is the hypotenuse on this one. H and X are what we want to find. So we put this in terms of X so that it translates very nicely over here. And then when we turn this triangle into a Pythagorean equation, we have this 13 squared minus X squared should give us H squared. So now it's just a matter of solving the system of equations to get the 2 variables. So I'm going to start by simplifying this first one up here. I want to make this a little bit easier. So I'm going to rewrite it just a little bit because, like I said before, I always like to have the X in front when I've got a polynomial like this. So I'm going to bring that minus sign in there, keeping everything else the same. And then I'm going to square this polynomial here to simplify it a little bit more. And in the process of simplifying it, I'll just go ahead and I'll square 15 and get my 225. Then I've got my x squared minus 28x plus 196. Notice again what happened. Because I had a negative x, the middle term ended up being negative. And when I squared the x's, I got x squared, so it became a positive number. So now I'm just going to carry this minus 1 through the parentheses, so I get minus x squared plus 28x minus 96. And then once I do all the math on that, it's going to resolve very nicely for me. I'm just going to have something that looks like a nice little quadratic equation. So I'm going to go ahead and square this 13 and get the 169 here, so that I've simplified it as much as I can. And now, since the h squared is on one side of the equal sign here and on here, it's going to be a simple matter of putting together a way to eliminate the h squareds by just saying, well, this part of this equation will equal this part of this equation. And I bring that in, and now we have it set up so that we can actually easily see that our x squareds here and here, since they're both negative on either side of the equal sign, they're going to end up canceling out, because whether I bring this x over here or this negative x over here, I'm going to have to turn one of them positive, and when the positive one comes in contact with the negative one, they both just go away. And so that just leaves us with only one x left in the equation, so much easier for us to handle. So when I start rearranging it, I have a very simple equation now. I can get it right down to this 28x equals 140. Now the next thing to do with that is to go ahead and divide both sides by 28, and it looks like it's going to be pretty easy. And once we do that, we see that we have x equals 5. Now we only have h left, because now we know what x is. And since this triangle over here uses just plain old x, we can actually come in and we'll just use this triangle's equation, which happened to be this one, and we can plug in, well, actually, even better, we'll use this one and we'll plug in 5 here. So 5 squared becomes negative 25, and then we take that right down to h squared equals 144, which all we got left to do now is take the square root. And again, if you know your square roots very well, you can easily see that this becomes 12. So h is equal to 12. Now that's great, because now we can take this 12 right here and we can just get it and go right back up into our equation here and put a 12 here. So again, A is 10 centimeters, B is 24 centimeters, and H is 12. So I'm going to bring it all back up here next to our copy of the formula for finding the area. I'm going to replace all the numbers, 10, 24, 2. Well, 2 was there already. The 12 that we got from H here. And now it's just a simple matter of addition, division, multiplication. And there we have it. The area of the trapezoid is equal to 204 centimeters squared. And remember, I'm always bringing centimeters back into it when I get down to the end. And in this case, since it's area, the centimeters have to be squared. So there you have it.